the USB tap, and like stuff is spread out everywhere. And I usually get stares, but people have actually asked. They're like, "What is that thing?"
Well, you like to sit on the aisle, right? So the big people on the inside are like, "Excuse me, I've got to go to the bathroom."
Yeah, so
and you're like, "Oh, don't touch that."
That's right. It's like I'm in the middle of single stepping through some code. You're gonna have to wait.
I'm single stepping, so this could take a while.
Yeah. So yeah, those are some pictures. What about laser engraving?
Well, we looked at a bunch of stuff. We wanted to acid etch.
Yeah. So we knew we were going to use an aluminum substrate board because aluminum was just cool, right? Like everyone else uses fiberglass, and the challenge of aluminum substrate is we needed to have everything on a single side of the board. So we'd have the front side clean. So we're like, all right, now we have the front side clean. What are we going to do? We've already done solder mask colors. We've already done different silk screen artwork.
Yeah,
Cutouts. Yeah. So it's like, what can we do, and what works great on aluminum? And it ended up being laser engraving. We looked at like sandblasting and actually etching instead of engraving.
Yeah, we did acid etching, but then you have to submerge the whole board, right? There's a problem where you couldn't protect the electronics.
Yeah. So this gets into the area that we've never tried. You know, we wanted to try something new and didn't know what it would turn out to be like, but we didn't want to completely sabotage the entire thing. So we decided to do the laser engraving, and Neil, of course, did all of the crazy, insane artwork.
Yeah, and it turns out you have to invert the art.
Yeah, you have to invert the art, and I think I might have a picture of that. But the real challenge was finding a vendor that wanted to do it, because every vendor's like, yeah, we'll laser engrave your coffee mug or your keychain. But it's like, can you laser engrave our circuit board? And they're like, what's a circuit board? And then they get all scared and everything. So it was really hard, and eTechNet actually ended up finding a facility in China that would do it.
Well, at one point we were going to Guatemala.
Yeah, or Guadalajara, yeah. I might even have slides on that. But basically the factory in China would do it, but they jacked up the price because they didn't know how it was going to turn out, and they would probably have to spend more. And then eTechNet jacked up the price in case they had to go and support it and everything. So the price was like, it ended up being like $6 to laser engrave it after doing the fab of the board. So we're like, oh, that's a lot. So we reached out to to some places in Guadalajara, which is some factories that Freescale uses, and since we have the connections to Freescale through the microcontroller, we reached out to just all our contacts. Like Ping reached out to all the people that used to do DEFCON badge manufacturing and everything, and it was like really nerve-wracking. And actually, I was in South Africa, and you were somewhere, and Ping was somewhere, and we all had this conference call trying to figure out what to do, and we ended up getting a slightly lesser price from the laser engraver in China. It ended up being like $3. But we figured it was safer to at least do that instead of having to ship badges to all different places to have them like.
We'd had problems with Chinese customs. I don't know a thing about Guadalajara customs.
Guadalajara, yeah. At least it's Mexico. You can like drive there and just smuggle stuff back, and like throw a few people in there as well.
You can pay somebody to smuggle it.
Yeah, right, exactly. So here's the process of the laser engraving. I didn't actually ask Neil if I could use these, but I'm sure he won't mind. So we started off with like this pencil sketch and pen sketch.
I was trying to say, we want to have this whole portrayal of like a whole hacking scene of all these different things going on. And when you combine all the badges, you get a large piece of artwork. And so this is his first draft where he was like, finally understood what I was trying to get at, and he kind of pulled this together. And so it was a good thing we got a picture of that before it disappeared.
Yeah, and this was a huge labor-intensive project. For him to do the artwork, it was like weeks.
Well, and the aspect ratio of it all, yeah. And then this is how it finally came out in a form that could be lasered.
And do you guys notice on your DEFCON or the Riviera Hotel keys that they match the image? Yeah. So if you can social engineer the people at the front desk, you can get all 7.
And then you get the whole panoramic
And you get the whole, yeah. And so the artwork is totally cool. So then we had to work with the laser engraver to actually like get it done. And what's funny is the laser engravers, a lot of them still use Corel Draw, like on Windows 1.
I think it was
like 3.1 or something. Yeah, really, really old equipment. So poor Neil, he sent me Adobe Illustrator CS, the latest
4.
Yeah, and we send that to the factory, and they're like, "What's that? What's Adobe Illustrator?" So there's a lot of back and forth to try to get into the format that they wanted, and they ended up doing it right, where the white part is where it's been lasered, and the dark part is where there's no laser. But we had it reversed, so the first set we got back was inverted, and we're like, this looks really shitty. So we tried it again, and it looked all right. And it's a little like sort of hologram looking. So yes, they do have all different images on them. You just have to look really carefully.
And they bill you for how long the laser dwells, right?
Yeah.
So how far down do you want to laser?
Well, you're renting time and everything, and we're like, can we make it more contrasty? And it was just too risky. So it looks awesome, and no one's done that, and that's what we like to do. All right, so some functionality. Early block diagram. This is a little more my style because they're just squares and arrows. We have the 56F8006, which is the Freescale part, and we have the display, USB to serial adapter, a bunch of interfaces and test points and some other things. So let's see. Let's go here. This is the same part we used last year. Do you guys remember that story where a bunch of these parts were stuck in customs going to the factory, and we had to order more to try to get those through, and those also got stuck in customs. So now we had like
50% more than we needed.
Yeah,
almost
it was like
100% more parts stuck in customs.
14,000 parts at one point stuck in customs, and then half of those got released and came to you guys on the badges, and then the other half, like 3 months later, got sent back to my house. So we had all of these badges. And
yeah, you can't return them 3 months later.
No, not after they're programmed and everything, and they've been sitting in customs. So we had these parts, and it's a great part, and I thought it would actually be cool to use it again because you guys who are hacking the badge are like familiar with it now, and you can do some like really cool stuff. So there were some things we wanted to do. We actually were talking about doing some wireless functionality and some other things, but this part in particular just isn't suited for that. So we're like, all right, what's it suited for? And we chose, sort of chose a design based on that. All the data sheets are on the CD, but they're also linked up there. For those that don't know, it's a pretty sweet part. It's like it's a 16-bit, essentially a digital signal processor. It's called a digital signal controller. It can do all sorts of cool like math functions and hardware-based accelerated stuff. 16K of internal flash. The PWM channel is what we used last year. I2C, everything you could want in a cool little chip. We're powering it from 3 volts, and there's a block diagram. So that one you should be familiar with, and it's it's just a nice general purpose part. This is the cool thing. This is like I wanted to use a display for a really long time, but the prices haven't been right, and we never knew how we were going to mount the display and everything. So this is a display from Kent Displays. And did you guys notice when you got your badges, like you could sometimes see the DEFCON logo on there? Because these things are super cool. It's like this cholesteric LCD, and the liquid crystal's twisted in some way that you don't need to refresh it. You can basically write to it, and you don't have to refresh it or apply any power to the display once you write to it, sort of like a Kindle or whatever. So you can write your image, and then it draws essentially no battery power at all unless you update it again. So during the test procedure, I had them put up the DEFCON logo, and then it would come to you. But you notice like sometimes it was fading and stuff because that if you push on the display, it will fade because you're not actually refreshing it. You're just like untwisting the crystals or doing something. So then you have to hit a button or put power back on, and it will refresh. It's just a really, really sweet little thing.
Well, in the battery life, in the past, we had these huge batteries, and you're like walking around with this big thing around your neck. And now this thing, what was the power consumption? It lasts. Yeah,
so I have a power consumption chart. So that I'll show you guys. But previously, it's always been a challenge because we want the badges to last the whole time and the LEDs not die and everything. So it's a really hard problem. So I'll show you the chart later. But the battery ends up lasting like 2 weeks. And it could be more, but there was a few little things that we put in so you couldn't actually end up like physically damaging the flash device if you're trying to reprogram it. But there's some other modes that we could have done to make it last like a year or something. But 2 weeks is good because you'll be home by then, hopefully. So yeah, a bunch of different specs. So this was another one of those companies where I saw their thing online. I'd seen them a bunch at different conferences, and I call them up and I'm like, hey, I'd love to use this cool display you have for this DEFCON conference. And they're like, DEFCON, what's that? And I explained the whole thing, and they're like, cool. And most companies, like most big companies, when you tell them what DEFCON is, they don't go, cool. They hang up on you. And then they don't call you back. So these guys were totally into it, and it turns out that the sales guy I was talking to is this old school ham radio operator and everything, and he gets it. So they gave us huge discounts. Essentially, they gave us 100,000 quantity pricing for almost 8,000 pieces, and it still cost $3.50 each because these things are like a brand new technology and everything. But it's just super cool, and it took a little bit of convincing, because it costs so much. But it's also like
most
cool.
expensive badge ever. But,
yes.
But the interesting thing is what was this originally designed for?
Yeah, so this was originally so actually it was not used in the first moon landing. For those who remember that. I guess nobody.
No, there's
it's like a totally different audience.
Yeah, but it wasn't.
Yeah, one person's like, yeah, I remember that. Dumbass, it wasn't 1968 or 42 or whatever. So yeah, this wasn't used in the moon landing, but it was originally designed for like the verbatim Insight USB hard drives, which you guys have probably seen, but they're for sale right now, and the display is used to show like the remaining hard drive space. And it's usually designed to be inside of a bezel and protected. So we were the first ones to actually use it in like this exposed environment. So we ran into some interesting things, and we actually just discovered a problem with their display with the power down modes, because it was something that verbatim had not needed. And then we start using our battery powered device, and we wanted to do all sorts of stuff in the sleep modes, and we totally discovered this bug, and they're like, holy shit. And I was like, holy shit, because we had like 4 days to get the firmware done. So they ended up sending us a revised version that they happened to have and just hadn't released yet. And it was good. So those guys are great to work with. And you notice like it's pretty slow to update the screen. So it's like 1.7 seconds, and that's kind of just the nature of the technology. The Kindle seems to flip faster. You sort of have, you have Kent Displays and you have E-Ink are the two companies that I'm aware of that do this stuff. Technology is slightly different, but these guys were excited about it, so we went with them.
You're going to talk about how you mounted it, right?
Yeah. I think I have a slide on the adhesive. So the internals for this thing's cool. It takes a serial interface, and there's a bunch of external capacitors and components to set up the drive voltages, and then it's just a standard serial interface, so it's very, very easy to use. And there's a bunch of sample code that they gave me, and basically like a few hours in, the display came right up. So it was like, yeah, it was pretty cool. Made me feel good. So here's the schematic, and I'll step through like a few of the different functions in more detail. There's a seamless power switch between the battery and the USB connector, because we figured if you're going to plug this thing into your computer and do all sorts of stuff with it, why drain battery power? So you can leave the battery plugged in and then plug in your mini USB to your computer, and now it's switching from the battery to the computer, which is cool. That was actually like the hardest part to design hardware-wise, even though it's like, oh, it's just a MOSFET and a diode. But I learned a lot about diodes during that time, and a lot about MOSFETs. So there's all sorts of debug and bootloader and some other things that I'll get into. Bill of materials, I always show this. Yeah, $14 per badge. That's not the only reason the price of DEF CON went up.
I remember the first DEFCON badge was like $1.20.
That was like five bucks. Yeah. But that's a big jump. And this actually doesn't include the cost of the Freescale processor, because we already had those. So it would have been actually like $16,
or your labor.
Or
it does include your labor in there.
Yeah, my time. Then the badge would have been like $35 a badge or something, 50. And the big ticket items were the LCD and the laser engraving was $384. So, but we wanted to try something new, and it's Jeff's money, so I figured we might as well just spend it. So here's the assembly drawing. All of these things are also in the CD, so when you do want to start hacking it, you'll notice there's no part designators on the actual board. These are the part designators. And some of you guys might have actually, like the last 40 badges were short a diode, and possibly short a capacitor, or maybe short a display. So now you can go to the Hardware Hacking Village and put them back on yourself. Yeah, I don't.
They'll see a sticker on the badge, though.
Yeah, well, you'll see an arrow on it. Just if you're right at the end, like the last 40 people or something. But we expect you to see you in the Hardware Hacking Village. And we're actually, with Jeff's permission, we brought all of the leftover components from previous badge builds. So we have reels of components and other things. You can come up and like grab some of the RGB LEDs from last year, like the microphones, and put them into whatever you're hacking on this year for the contest. So free hardware. Here's the back side. You have your two switches. On the left side, your FTD